Hello learners, now a quick one here. Now let's solve this maxima and minima problem on quadratic equation. Okay, so we have, this is a question on how to find, for us to find the maximum height reached by the stone when and the time at which this occurs. Okay, so we have a stone is projected vertically upward into the air with an initial speed of 30 meters per second. Okay, 30 meters per second. Its height h meters above the point of projection at a time t seconds after the instant of projection can be approximated by the formula h equals to 30t negative 5t squared. Okay, so we want to find the maximum height reached by the stone and the time at which this occurs. So now, like I said, when it comes to when it comes to maxima and minima problem in quadratic, okay, um, it is important for us to understand, the nature of the graph. That's the nature of the what? Of the parabola. Okay. Now, when we talk about the nature of the graph, and then also this is very important. There's what we call vertex. When the function reaches the minimum. Okay, that is, for instance, when the value of the leading coefficient in a quadratic equation is positive. Okay, then it means that the parabola will be what? Will be U-shaped. That is, the parabola will be U-shaped. Okay, and the vertex will be the what? Will be where the function, okay, reaches the what? Minimum. Yes, that's in the case of when it is a U shape. Okay, I'll explain that. Okay, so like I said, when we talk about maxima and minima problem in quadratics, okay, now I said, now let's consider the general quadratic equation, which we know to be ax squared plus bx plus c equals to 0. Now, we need to note this point, okay? Now, for the parabola of a quadratic function to be U-shaped, okay, it will mean that the vertex of the what? Of the function, the vertex will be where the function reaches what? Minimum. What I'm saying is that, now, note, this is to be noted. Now, number one, okay, if a is greater, okay, the parabola will be what? U-shaped, or we can just say is U-shaped. Okay, and the vertex is where the function the vertex is where the function reaches the minimum. The vertex is where the function reaches the minimum. So it's like this. It will be U-shaped, okay? It will be U-shaped. So the vertex is where the function reaches the minimum. Okay, the vertex is where the function reaches the minimum. So this is the U-shaped parabola. Okay, so the vertex, okay, when we have a U-shape, because the leading coefficient of the quadratic equation is positive. Okay, so then the vertex is this line which cuts the parabola at this point here. Okay, so the value here, okay, the value of x here is what we call the vertex. So to be able to calculate, okay, let's, before that, so we have, if a is greater than 0, the parabola is U-shaped and the vertex is where the function reaches the what? The minimum value. Okay, now also case now number 2, if a is less than 0, okay, that means that the parabola is inverted U shaped. Okay, it will be, let me say, is N shaped. Okay, and the vertex is where the function is where the function reaches the maximum. Is where the function reaches the maximum. The vertex will be where the function reaches the maximum. So in this case, it will now be, so this is when a is greater than 0. That's for this quadratic equation. But when it is now negative, okay, so it will mean that a will be less than 0. So for a less than 0, we have, this is the x-axis, y-axis, negative x, negative y-axis. So we have the y-axis, the what? The positive x-axis, the negative x-axis, and the what? And the negative y-axis. So this will now become the maximum. So the vertex. Okay, so we're talking about the vertex. So the vertex is where the function reaches the what? Maximum. That's the vertex. So now, to be able to calculate the maximum height reached by the stone, okay, so we're going to use one of these, to solve this question. So what we need first is to what? Is to write the equation for vertex, the parabola of this function. So what we are given is, we're given h equals to 30t minus 5t squared. Okay, so to be able to calculate the maximum height, so we need to first find the value of time t. So to calculate the value of time t, okay, so time t, okay, to calculate t, okay, to calculate t, we make use of the word vertex. Okay, so we make use of the vertex. This will be, t will be in terms of, that's t, normally when we talk about vertex, okay, vertex is x equals to negative b over 2a. Okay, so from this quadratic, okay, this will be negative a. Okay, a will be, this is negative 5 is what? A will be negative. All right, so then b will be 30. Okay, so the value of t, now let's say we have this function expressed in terms of, that is in terms of x, you understand? So that's what, so which means t will now become x, that is x will be equals to t. So we then have t to be equals to negative b over what? Over 2a. And this will be t equals to minus, so we have b to be 30. Okay, then a to be what? A to be negative 5. Okay, so this will become, so we have t to be negative 30 over what? Over negative 10. So the time t will be what? Will be 3 seconds. Now, because this is a maxima and minima problem, okay, on quadratic, okay, that's why I needed to explain this first. Okay, we have 3 cases in this case. The other one is when y equals to 0 has a root, whatever. Okay, but what is important here is to understand that when the value of the leading coefficient of a quadratic function is greater than 0, the parabola will be what? U-shaped. And the vertex is where the function reaches the what? Minimum. So it will be negative. Okay, but in the case of, yes, this is minimum. Okay, it will be, yes, it will be, this is the vertex in this case. Now, then also we have, if a is less than 0, that is when the leading coefficient of the quadratic equation is less than 0, then the parabola is what? Is N-shaped. Okay, or we sometimes call it inverted U-shaped. Okay, and the vertex is where the function reaches the what? Maximum. So in this case, we want to calculate the maximum height. Okay, so this is a graph of height versus time. But because we are familiar, this is quadratic. So because we are familiar with the, the general quadratic equation, which is, that's the general form of representing quadratic equation, which is the ax squared plus bx plus c equals to 0. So that's why I have to use x, but what is important here is to understand that x is equals to t. Okay, x is equals to t, where h represents what? Y. Okay, so now, so we just found t. So the maximum height, now to calculate h, plug in the value of t into the original the original what? Equation. What is the original equation? H equals to 30t minus 5t squared. So H will be equals to 30 multiplied by 3, okay? Negative 5 multiplied by 3 raised to the power of 2. So that H will be 90 minus 9 times 5, that will be 45, okay? That will be 45. So this will be equal, this will be H equals to, I think the unit selected in this case is, what unit is selected? Okay, that's meters. So the maximum height will be 45 meters. Now, this is very important. Let's also understand that now when a stone is projected vertically upward, it will be giving some velocity. That's for the stone to move. It will be because it is giving some what? It is giving some velocity. Okay, there will be a velocity at which it is projected upward. So why the velocity is not important or not necessary is because, of course, for an object to be released from the surface of the earth, to be thrown upward, okay, for now the object will move when it is giving some velocity. So the velocity the object is giving is 30 meters per second. Okay, so and a body will not move when the velocity is what? Zero. Or a body at rest will have a velocity equals to 0. Okay, now but when a body is moving, so it means it will be moving at a particular speed or velocity. So this velocity is not necessary. So now above the point of projection, so what we need here is to calculate the time, okay, and also to what? To calculate the what? The maximum heights. So we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye bye.